So today we're going to learn about systems of linear equations. And let me go. Okay. So first we're going to do like a pretty simple and fun Desmos to introduce the topic. And then we're going to learn about what systems of equations are, then do a tiny bit of practice and a Kahoot. Also, I don't know if you saw the Google Classroom post. I kind of forgot to post the homework, so it was your unintentional Halloween treat. Okay, let's do this Desmos. So, oh, wait, I don't want that. Can you put like the link in the chat or
Sure, I got it. Okay, so click the link in the chat and then join the Desmos.
So we're not working with a group, just start the activity and um we'll go through it together. 1 second. I guess I'll go from here. Actually, then you can see all the responses. I'll just do it from here. Okay, so the first slide, this is just kind of getting you introduced to what this weird hanger thing is. So you see that there's like two X blocks and then a 3 and then a Y on the right. So you're trying to balance it so that's straight. So let's see, I'm gonna put in 1 and 5. So 1 plus 1 plus 1 plus 3 is 5, and then 5 is 5. Yeah, it balances. So you guys can do that too if you want to. Pretty simple. And then this is just kind of introducing what this is. So obviously I could have put in other numbers into this x and y and it would have still balanced. So these are some of the numbers that you could have put in. There's a bunch, as you can see. And this kind of looks like a line, right? So this time, let's do this. Find 3 different pairs of x and y values that will balance the hanger by moving the point. So you like put it somewhere and then you try it. Like that didn't work. So once you do it all, I guess we can talk about it a little bit. Tell me what you think is going on.
Was there an answer for the first one? I didn't get it.
For the first like screen?
Yeah, the one with the two X's, the 3, and then the Y on the other side.
Yeah, so this one doesn't have like one answer. I could have done a lot of different things, but as long as it balances, it's okay. So like I did 1 and 5, but I could have done let's see. I could have done like 5 and 13, and that would have still worked. Oh, not the one. 13.
Okay.
Okay, so if you're like kind of done or have a couple of points, then How about you like put it in the chat and I'll test it out on my screen. So I'm going to test out one first. So let's see. I have 2x's and 1y and then 15. So, what can I do? I could do like, let's see, I could do 2 and 11. 2 and then 11. Okay, so somebody told me 7, 1. Let's see if that works. 7 is right here, and a 1. That also works. Interesting. 5 and 5. Okay, let's see if that works. That also works. So if you see a pattern, I feel like maybe this might be in some kind of line like this. So let's try another point that would be on the line if there was a line. Okay, that works. That also works. So what we see is that the like pairs, like coordinate pairs that would make this work are arranged in this line. So we can go on to the next one. Too far. Okay, this time you're gonna try to balance both at the same time. So you can move this around. And obviously, like for hanger A, for example, points on this line, this red line, are gonna make hanger A balance. And then the points on this line will make hanger B balance. So try to find the point that would make both of them balance. Once you find it, you can type it in the chat.
All right, so has anyone found the point yet? You can see, like Kayang said, that everything on the red line is going to make hanger A balanced, and everything on the purple line will make hanger B balanced. So where's the point that lies on both lines to make both of the hangers balanced? You can kind of like drag your mouse around on the graph, and then it'll tell you the point.
3, 9. Ooh, let's try that one. So 3, up, 9. Yeah, so that point is the point where both of them are going to be balanced. And you'll see what this means in a more like formal way in a second. But if I have two lines that are graphed, the point where they intersect, where they meet, is going to be a solution for both of them.
All right, so this slide tells us that the point 3, 9 is a solution to the system of equations. So the system of equations before was represented by the hangers, but now you can see them written out. So 2x plus 3 equals y, and 2x plus y equals 15. Those two are called a system of equations, and there's going to be one point where they intersect, which is the solution, because it makes both of those equations true. Now, you can drag your mouse to the point 2, 7 on the coordinate plane and see if it's also a solution. and then type yes or no in the chat. So remember, for it to be a solution, it has to make both equations true. All right, anyone have any ideas? 2 comma 7.
So that'd be like right here.
Yep. So you can see that 2 comma 7 is on the red line. Yeah, good. Someone says no, so that would be exactly right. Good job. 2 comma 7 is not a solution to the system of equations. It does solve, it is true for one of the equations, 2x plus 3 equals y, but it's not true for the other equation. So it's not a solution to the system of equations. Yeah, exactly. Colin proved that it doesn't match up for 2x plus y equals 15. Okay, so next we have another set of systems of equations. And you can use either the graph or the hangers, but just try and see which one of the following points solves the system. So like the previous one, that would just be the point where they intersect. And then mark your answer. You can also type it in the chat. All right, so I see that 3 of you have answered 4 comma 6. So Kayang, will you show 4 comma 6 on the graph?
Yeah.
Yep, you guys are correct. So 4 comma 6 is the solution to the system of equations. And you can also plug the values back into the equations just to prove that that's right. So we'll do the second one. 4 is x and 6 is y. So 3x would be 12, and then 2y would also be 12. So then 12 equals 12. That would solve that system of equations.
And we'll get more into the like algebra details when we go back to the slideshow.
All right, and if anyone has any questions, feel free to ask. Right, so now this one is an interesting one. Is it possible, can you balance both of the hangers, or can you find a solution to this system of equations?
And this is a really big hint. These two lines are parallel. And if you think about what the definition of parallel is, this would give you a big hint. Ooh, I see a good answer in the chat.
Yep, it is impossible, because like we saw previously, the solution to these systems is where the two lines meet. But when they're parallel, they're never going to meet. So there's no solution, there's no single point that makes both of the equations true.
I think we can skip this one. Not very important. Okay, let's just do this, the ninth slide. So the ninth slide is asking you if you can balance both of these at once? Or can you balance just hanger A while hanger B is not balanced? Is it possible to balance only one of them at a time? Yeah, so both of them are always going to be balanced. So it's either none of them are balanced or both of them are balanced because they're the same line. So this is when you would have an infinite number of solutions. Okay, so this one is kind of hard. So if you don't get it, that's okay. But actually no, at this point we're not going to do this one. Let's just go back to the slideshow. Okay, so the second thing is learning about systems of equations. So does anybody know, like, based on what we just did in the Desmos, how to solve systems of equations? Or have you at least heard of them? So you can like unmute and tell me or tell me in the chat.
I think it's just balancing out and isolating variables.
Yeah, kind of. So it's like when you have two or more different equations.
In the same
Anybody like
equation.
completely familiar?
Yeah, I think it's, I don't really know. I'm just going to stick with balancing out the equations and simplifying them.
Okay. So yeah, that's okay. I expected that most of you wouldn't know what this is. So I think you learned this topic maybe when you're, I would say 7th grade, or maybe even 8th, somewhere in like later middle school. But basically, systems of equations is just like a fancy title for two or more equations that share variables. So oftentimes the number of different variables will equal the number of equations given. So for example, this one, I have three equations and I have A, B, and C. Those are my three variables. So these variables are being shared in the three different equations, and there's three equations and three variables. Just a thing to notice. So there's four main ways to try and solve systems of equations. And what I mean by trying to solve is that like we did on the Desmos, trying to find a point that would make all of the equations true. So you can graph it like we did. You can use this thing called substitution. You can do this thing called elimination, and then equal value method. So Yolanda's gonna do the first two.
All right, so think back to the Desmos and remember how we plotted two different lines on a graph and then found the point where they met. That's how you can solve systems of equations through graphing them. So the point at which they intersect will be the solution. You can also it also makes it easy to see how like there might be no solution if the two lines are parallel, or how there's going to be an infinite solution if the two lines are just the same. But usually this takes a long time and it's not that helpful for a math competition.
Yeah, so if you're in math counts or something, it would probably be much quicker and easier for you to do it algebraically. Unless it's like a geometry problem.
Yep. So we're going to go over one of the ways you can solve it algebraically. And so this is called substitution. So substitution is where you can just replace one of the variables and represent it using the other variable. So when you look at this equation, you can pretty much, once you have some experience, you can see that it's going to be easy to solve it with substitution because the second equation is y equals 8x. And that tells you that you can just take 8x and substitute it in for y in the first equation because y equals 8x. So they're the exact same thing. And then you can change the first equation into 2x plus 8x because that's the same thing as y, equals 5. Then you get 10x equals 5 because you're combining the like terms. And then if you divide both sides by 10, you get x equals 1/2. Then you can go back, and since y equals 8x, y will equal 4 because 8 times 1/2 equals 4. And so figuring out what type of method to use for each equation, for each set of systems of equations, is just something you get better at with practice and recognizing the patterns.
So our answer would be this point. That would have, this is like the format your answer would be in.
Yeah, 1/2 comma 4. All right, so for this, so the first thing you've got to do is just set one of the variables equal to an expression. And the expression cannot have like that variable inside of it. So you can have y equals 2x plus y. That doesn't work because if you substitute in 2x plus y, you're not even making the equation simpler at all. You want to substitute it so like one of the equations will only have, say, x's or something to make it easier. That would cover step 2. So substitute and replace. And then you follow the normal steps for simplifying the equation and solving it if possible. If there's more than 2 variables, this will just get more complicated and you might have to substitute multiple times.
You don't need to worry about the step 4 for now because we'll go over that in more detail next class.
All right, so example 1, solve using substitution. So first we have 4x equals 8 times the quantity of y minus 1. And then our second equation is y plus x equals 13. So first of all, which one of those equations would be easiest to change into the form? Say we want to isolate y and replace, say we want to isolate x and replace x with y. Which one of those equations would it be easier to do that? Like if you just change one thing about the equation, you can isolate x on one side. Would it be the top equation or the bottom equation? Does anyone have an idea? All right, that's okay. Well, it would be easier to do it with the bottom equation because that's just y plus x equals 13. And if you want to isolate x on one side, then you can just subtract y from both sides. This sets it up so that it's easy to substitute in something for x. So we get x equals 13 minus y, right? And then you can go back to the top equation and replace x with 13 minus y. So you can see at the top there's 4x. You replace that with 4 times 13 minus y. And this makes it so that the top equation only has one variable, which means you can solve for what solve for what y equals. So then if you expand, you get 52 minus 4y equals 8y minus 8. And then you can add 4y to both sides and add 8 to both sides. Then you get 60 equals 12y. Yeah, 60 equals 12y. Then you divide both sides by both sides by 12, and then you get 5 equals y. Then we need to figure out x as well. So y plus x equals 13. And if y equals 5, then what is x? Type your answer in the chat. 5 plus x equals 13.
Ironically, my teacher had like the simplified version. Ironically, my math teacher had a little thing kind of like it. It was just 5 plus what equals 13.
Oh,
For whatever reason, that specific problem was on the board.
That's funny. But yeah, so the two of you in the chat are right. So 5 plus 8 is going to equal 13. So y equals 5, x is going to equal 8. And we can write our answer in the form of like a coordinate point. So that would just be 8 comma 5. So the most important thing to take away is how we set up the equations so that we could substitute in something for x to use substitution to solve it. So let's do the same on the other side. So change one of the equations up there to make it so that we can substitute. Change the second equation because that one's easier. All right, and then type in your chat. Type in so that we can substitute out either x or y. It doesn't matter which. Y equals 8 minus x. Yeah, that's perfect. So you just subtracted x from both sides, and now you have y isolated. So you can simply replace y in the top equation with 8 minus x. Yeah, great job. So let's do that. So 3x plus 2y equals 19. So we're going to write 3x plus 2 times 8 minus x, because that's the same thing as y, and then that equals 19. And now we simply use the same like sort of variable solving strategies that you're used to, right? So 3x, and then we're going to distribute the 2. So that's 3x plus 16 minus 2x equals 19. And continuing to simplify, we get x equals 3 because we subtracted 16 from both sides. So x equals 3. And now if x equals 3, what does y equal? Type your answer in the chat, or you can say it out loud. Remember, go ahead and put it back into the previous equations. All right, yeah, 5 would be correct. Y would equal 5 because, like before, you said y equals 8 minus x. So 8 minus 3 is going to be 5. Yep, perfect. So does anyone have any questions over how to use substitution? All right, if not, then Kayang will discuss 2 other strategies we can use.
All right, so this is another algebra one, and I think this one might be my favorite out of the 4 that we're learning this time. So it's called elimination, and it's basically like what the name says. So you eliminate or remove variables until there's only one left. And how do we do that? So you basically multiply an equation by a number, or add and subtract an equation onto another equation. So that may sound really confusing, but basically it's pretty cool. What you do is, so I have 2a plus 3b equals 18, and 4a plus 3b equals 10. What's in common in both of these? Well, I see that there's a 3b in both of them. So I'm allowed to subtract an equation from another equation. So I'm going to subtract this whole equation, the second equation, from the top. And if I subtract, on the right-hand side, 18 minus 10 is 8. On the left hand, 2a plus 3b minus 4a plus 3b. So these would cancel out. And I'd be left with negative 2a equals 8. So then now I only have one variable, so I can just solve it. And I would get that a is negative 4. And I can put this back into the one of the equations, doesn't matter which one. 2 times -4 plus 3b equals 18. I'm using the first one. This is -8 plus 3b equals 18. Add 8 to both sides. 3b equals 26. I think I'm doing this right. Divide by 3. Oops. B is 26 over 3. So my answer would be -4, 26 over 3. So basically, this time I just had to subtract. Sometimes you'll have to multiply the whole equation by a number and then add or subtract. So we'll see more examples as we go on. But the basics is that you're subtracting or adding equations together to make some variables go away. Alright, so the first example, I'm gonna walk you through this one. And then the second one, how about if somebody feels confident, they can try to do it and walk us through it. So let's see. Let's do this first one. Solve using elimination. So first, I see that there's this -y, well, -y, and then this +y. So what happens if I add the equations together? Well, on the right hand, it'd be 22 plus 3, which is 25. On the left-hand side, it would be 22x minus y plus 3x plus y. The x's add together, so it's 5x. This is really annoying. And then the y's, they have opposite signs. Sorry. So they would cancel out. So I would just have 5x. Now, if I delete some of these, for some space. Uh-oh, that is not what I wanted. Bear with me. Anyways, so we got down to the point where it was 5x equals 25. Right? Now I just solve for x. X is 5. Put 5 back into one of these. Let's do the second one. 3 times 5 is 15 plus y equals 3. So then y must be -12. Does that make sense? Any questions about how I'm adding equations together and simplifying it? Okay, does anybody want to like do the second one on their own and show us, like type in the chat what the answer would be?
I'll
Or
do it.
does anybody, you know it?
Yeah, I'll try.
You want to do it?
Yeah.
Okay, you can walk us through it. So I'll like write
Okay.
as you tell me what to do.
Okay, so I think this is one where you have to add. So you do 3x plus x, which is 4x.
1 second.
Sorry, I talk fast.
Yes.
Then you have to do 2y plus y, which is 3y.
Okay.
Then you do 19 plus 8, which is 27. So then
So I'm going to interrupt you for just a second. So I kind of gave you a harder question. The second example is kind of much harder and we haven't really done it. So basically, you gave us like a good example of what happens in this type of problem. So yeah, you could have added, but then we still have two variables here, so we can't solve. And you wouldn't have known this, so that's all good. But what you would have to do is,
I'm sorry.
that's okay.
My neighbors are just playing outside.
Oh yeah, I think I might have a really loud background right now. Hopefully you can't hear everything, but it's pretty loud.
I'm sorry,
Anyways,
just like playing right in front of my house.
so
So is
well,
mine.
let's see. I'm gonna eliminate the y's. So I'm gonna multiply the whole equation by 2. Well, why do I want to do that? You'll see in just a second. So x plus y times 2 becomes 2x plus 2y. And then 8 times 2 is 16. So now I have this new different equation. Okay. But now, this one, then what's in common? The two y's. So now if I
You can
subtract,
cancel
I
it
can
out.
get rid of something. So you
So
want
the
to take
y
it from here?
can, so the two y's can cancel each other out, which makes it 2x plus 16, and 16 divided by 2 is 8. So x is equal to 8.
It would be 3x minus 2x. What's 3x minus 2x?
1x.
Yeah, so it's just x. You were very close. Yes,
Oh.
x equals 16. So what's y then? I don't know if you can see it because I wrote.
So if x is, so if we go back to if we go to 3x plus 2y equals 19, if that's the case, then 3x times 3 would be 48. So that would be 48 plus something times 2 equals 19. And the only really logical solution would be a negative number. And I think that negative number would be the, I don't know exactly what it's called, but whatever,
Okay.
49,
Wrong thing.
48 minus 19,
Oh, wait, never mind.
48 minus 19 is, and then add a negative sign. I think it's the absolute value.
Let's see, what is 19 minus 48? That would be 29, I think.
Yeah, so 29 divided by 2 is something around
You don't,
14.5. So y equals negative 14.5.
okay, you think it's negative 11.
No, I said 14.5.
Well, somebody in the chat.
Oh,
Okay.
sorry.
I think,
I don't have the chat pulled up.
like there's a slight mistake at the start where remember how we
Where?
got to 19 minus 16, but we kind of forgot about that part. So it should be 2x plus 2y equals 3. I think it just got covered up.
Oh,
Got confused.
you're right. Okay. So it had to be. Oh, okay, so x is 3. Yes, that makes more sense. I didn't see it. Okay. So actually, I have to do 19 minus 16. So this would be 3. Sorry, this is kind of confusing. Then it'd be 5, right? So it'd be 3, 5.
Now it's a lot easier.
I don't know where the negative 11 came from then. Okay, so let's just make it less messy. Yeah, but other than the one mistake that I didn't notice, it was all right. So good job. Thank you for walking us through it. Oh, no, that's okay too. It's always good to try. So basically what we did is we multiplied this by 2, which gave us 2x plus 2y equals 16. Then you have to subtract x equals 3, put 3 back into here, y equals 5. 3 comma 5. Okay, I think most of us should be getting it somewhat. Let's move on to the next and our last method. Let's see. Okay. So, it's called the equal value method, and it's kind of interesting. It's not used that much. So, first we're gonna think about this little thing on the right, this notebook thing. So it says, think about it. If A equals B and A equals C, does that mean B equals C? Is that true or false? If A
I
equals
think
B,
it's true because A and B are the same value, and C is the same value as B by that. So B is always equal to C in that case.
Yeah, you're right. So A equals B, A equals C, then B has to equal C, right?
It's the triangle of equality.
Yeah. So using that same logic, I'm gonna look at these two. If y equals 6x plus 8 and y equals 3x plus 7, does that mean 6x plus 8 equals 3x plus 7? Is that true?
Yeah, since they're
Yeah,
both equal to y.
they're both equal to y, so they have to be equal to each other. So when there's two equations in the format like y equals something something, then we use this equal value method. And it's pretty helpful. So now I just have an x, right? So I can just simplify. Subtract 3x gives me 3x. No, that's not what I want. 3x plus 8 equals 7. Subtract 8. 3x equals negative 1. So then x is negative 1/3. Now I just plug it back in to find y. So I guess we'll plug it into the second one. Y, oh my gosh,
Equals 8.
does it equal 8?
Yeah, because 3 times negative 1/3 would be, oh no, that's negative 1. So plus
Yeah.
negative 1 would be 6.
Yep, you're right. It is 6. So my answer would be negative 1/3, comma 6. Good job. Okay, now let's do some examples. So, anybody want to do one of them?
Can I go again?
Yeah, sure. Try again.
Okay, round number 2. So if we do the same thing you guys did last time.
Mm-hmm.
So last time what you did, you subtracted, I think, so I think you might, for example 1, I think you might need to switch the equations around
Okay.
and subtract.
So you're kind of close, but
Or should I? Oh no, we can add.
no, we don't add. So here you do y equals this thing, and y also equals this other thing. So these two have to be equal, right? So you just set them equal to each other. So you would set it like 2x plus 7 equals 5x
I'll
minus
do
5.
that. Okay, so then
And
you stack them together, and so that would be 7x equals 2, I believe.
so we're just solving the equation. So I'm gonna move my 2x over here and
Um,
then add 5. I think you might be getting it confused with the last thing we did.
yeah, I think I am. So 2x, so that's 0. 12 equals 3x, and 12 divided by 3 is 4, so x is equal to 4. And then if we plug it into the, I'm going to do the first one.
Okay.
So if we plug 4 into the first one, 8 plus 7 is 15. Y
Yep,
15.
you're right. Good job. Okay. Anybody want to do the second one? Somebody different. I hope at least somebody else knows what's going on. So,
I'm
everybody,
not sure if I do.
who said that?
Do it, Colin.
No.
Just give it a try.
The person who said something about doing it, do it.
Yes. Whoever said it, let's go through it together. Who said that?
Colin.
Is it Colin?
Perhaps.
It is you. I saw you on mute. Okay. Oh, wait. Let's first look at this question. How do you know to subtract which number by which? So I think this might have been a confusing explanation. Basically, you're not subtracting anything right now. I mean, you are during one of the steps, but what I'm doing is, so with our like A equals B and then A equals C example. So then B equals C. So that's what I'm doing here. If y equals 2x plus 7 and y equals 5x minus 5, then I can set these two equal to each other, since they're both equal to y. So that means they are equal to each other. So that's how I came up with this equation. And then I just solve for x. Then I plug it back in. Does that answer your question?
So my question is basically like not like about the problem, but like it's so you know like below like you did minus 2x plus 5 minus 2x plus y. How do
Yes.
you know which number like you have to subtract?
Oh, okay. So that one, you have some freedom over what you want to do. So you don't have to subtract 2x. You could have subtracted 5x. It doesn't really matter, but basically, as long as you're isolating the variable, uh-oh, I did it again. As long as you're isolating the variable, it's okay. So, like, you're right. I don't have to subtract 2x. I could have subtracted 5x.
So like you can do 5x minus 5x, so then that would lead to 0, and then
Mhm.
2x minus 5x would be equal to negative 3. Yeah,
X, yes.
negative
Now,
3.
I have
So
this, right?
yes.
So now I have to still isolate the term with the x in it. So I have to subtract 7 this time, so that this is alone on one
So
side.
so how do you know like that like you have to subtract 7 from 7 and then 5 from 7?
So what I'm doing is I'm trying to isolate the x, right?
So you're just subtracting each number that like is in like the positive side, right?
It doesn't have to be positive. Like, if this was a -7, I would have added 7 instead.
Oh, okay,
I
yeah,
just
okay.
do something that would make all the numbers be on one side and all the variables on the other side.
Oh,
I
okay,
do
yeah.
the same thing to both sides.
Yeah, okay, yeah.
You
Yeah.
get it?
Yes.
Okay, that's great. But no matter how you do it, you would get the same answer. So,
Yeah, okay.
okay.
All
So,
right, Colin,
Colin,
have you been
you want to
getting
do too?
nervous? Sitting there waiting.
I don't know.
Okay, so let's do this together. First,
Well, I mean, I'll try.
equation. So using like the thing where it was A equals B and A equals C, then that means B equals C. So using this same logic, set an equation using these two with only the variable x in it, okay? No y's.
So is that for me?
Yeah, that's for you.
Okay. So, it says in the equation that like the more x's, the smaller number you need to subtract it for it to equal y. So I'm guessing x is a negative number because like I think well actually I'm not sure.
You're not sure? Okay, that's okay. Let's do this. So, okay, do you understand what I'm saying when A equals B and A equals C, B equals C?
Somewhat, I guess.
Somewhat? Okay, let's do a different example. Okay, let's say I'm 15 years old, right? So I'm 15 and my friend is the same age as me.
I'm 15.
Yeah. So I'm 15. My first friend is the same age as me. And I'm 15, and my second friend is also the same age as me. So then does that mean my friends are the same age? Is that true?
Yes. Yes.
Yeah.
Yeah, okay. So then if number A equals number B and number A equals number C, then does B equal C?
Yes.
Yes, okay. So then let's apply it to the question. If y equals this thing with like x's, 3x minus 9, this whole thing, and y also equals some other x thing, x equals x minus 11, then do the two x things equal each other?
Yes.
Yes, okay. So then I'm gonna set it equal to each other. The first x thing that I'm calling them x things, and then the second x thing are gonna have to be equal to each other using just some logic. Now, can I solve this for x?
I guess.
Yes. So, how do I do this? You want to do this part? Colin?
Hmm. I don't know. Sure.
Okay.
I don't know. I'll try.
Okay, that's good. If you don't want to, I can do it, but it's good to try.
Okay. Okay, so I don't. So I
You're
guess.
solving this equation.
Okay. I don't.
Remember, try to isolate x on one side and then put all the numbers on the other side.
Okay, so like, could I subtract 3x by the 1x?
Yes, that's good.
Okay, so then 2x minus 9 equals negative 11?
Yep.
Okay. So,
So now I want all the numbers on one side as well.
so would that mean 2x would be equal to negative 2?
Yeah, that's right.
Would negative 2 minus 9 be 11? Negative 11?
Negative 2 minus 9 equal negative 1. No, you were right the first time. So now I'm moving the negative 9 to the other side, kind of. So it'd be 2x equals negative 2. Okay, now what is x?
Oh, okay. So x would be negative 1.
Yeah, you're right.
Okay.
Good job. See, you're doing it.
Yeah.
Okay, now how about we put it into the second equation?
Well, that was nerve-wracking.
So let's put negative 1 into x. So y equals negative 1 minus 11. So what is y?
Negative 12.
Yeah, it's negative 12. So your answer would be negative 1, comma, negative.
So can't you do it the other way? Like, see, like you can, subtract 3x by minus 3x, so then that would be 0. Then you can subtract minus 11 by minus 3.
Yeah, so are you saying that we could have, yeah, so you're right, we could have done it a different way from here too, and that would still give us the same answer. But yeah,
Okay,
you're right,
yeah.
we can do it different ways.
Okay.
Okay, so great job, guys, and thanks, Colin, for stepping up and doing it. See, I knew you could do it. Okay, so now we're gonna do some practice. But what time is it first? 3:59. We'll do like
2 or 3, I guess.
1, 2 problems, then we'll go on to Kahoot because I think everybody likes Kahoots better than practice questions. Okay, so for the next few problems, it says to first identify the best method to solve it, but I'm gonna just tell you the best method to solve it for now. Okay, let's do this one. This one is similar to what we just did. So I'm gonna give you a hint. We're gonna use the equal value method, which is the one we just did, where you have y equals something, and you set the other portions equal to each other. So somebody, you can like write on the Jamboard. Oh wait, I didn't give you a link, did I? Copy link. Everyone. Okay. So once you go on the link, somebody tried to write an equation that would just has x in it, and that we could solve for x. And one good thing about this is that nobody can tell who's writing. So if you get it wrong, that's nobody can tell who got it wrong, if that helps you any. So somebody be brave and try to set up an equation. Ooh, I see a really, really, really good one. Okay, yes, you're right. So y equals something else. So this must equal this, using our handy-dandy logic about a equals b equals c and b equals c. So yeah, we're gonna do 3x plus 8 equals 22x minus 11. Anybody want to do this one? You can write it, or you can talk to me and I'll write it down for you.
Can I do it?
Yeah,
Yeah, okay. So first you do 3x minus 3x.
great.
So like yeah, 3 yeah, okay. Yeah, so that's 0 and then 22x minus 3. And then that would be 0 and then 8.
What's
And then
22x minus 3x?
yes. What?
What's 22x minus 3x?
22x minus 3x is 19.
Yeah, okay, great job. Now what do I do?
And now you would do 19x minus 11, which is 8.
Not quite. I'm gonna move my negative 11 to this side. So how about
Oh.
add 11? Since this doesn't have x, it's
Oh.
just an 11, so you can't really do that.
Oh, okay. Okay, yeah, so you would subtract both of them and then you would get 19 equals 19x. Yeah.
So what's x?
X is 19.
Are you sure? Look at this again. 19 equals 19x. X would be what? If I put 19 in here, that's not going to equal 19.
So 0?
Very close. If I put in 0, then 19 times 0 is 0. And 0 doesn't equal 19.
1.
1. Yeah, it's 1. Okay, great job. Now, plug this back into the original equations. So let's just do this first one. Y equals 3 times 1 plus 8. What does y equal? Somebody tell me. Ooh, I see one that's on a sticky note. Anybody want to say it out loud?
Y equals 11.
Yeah, great job. So this is the correct answer. Kudos to this person for helping us through this entire problem.
All right, so problem 2. This one's going to be a bit trickier, but we're going to use the substitution method, okay? So I'll give you a hint. I'll rewrite one of the equations to make it easier, and then someone can tell me how we might use substitution for this. So yeah, we're going to take that first one over there, and what we're going to do is we're going to add 7 to both sides. And that puts y on one side all by itself. So we get y equals 2x plus 7. And now we're going to try to substitute in something for y. We're going to substitute out y in this next equation, and we're going to write y in terms of x. Okay, so does anyone have an idea of how we would do that? You can write your version of this on a sticky note. Think about it like replacing y with 2x plus 7. We don't want y, okay? Who likes y? We only want x in our equation.
Oh, I see a really good answer.
Yeah, we have, yeah, so that's how you would do it. So instead of having this y right here, we get rid of that, and we're going to write 2x plus 7 where y used to be. And then we have the rest of our equation. So yeah, okay, it's oops. And now we have just a normal old equation. Does anyone want to walk us through how we would do this one? You have to do a bit of distribution, so it might be a little bit more challenging.
Maybe somebody that hasn't walked us through one yet. If somebody's brave, we can help you. So,
I can.
okay.
Yeah.
So for this one, first, to solve for the parentheses, 5 times 2x equals 10x, and 5 times 7 equals 14. So 5x plus 14 minus 2x equals 11. So then from here, we can just do 10x minus 2x. So 8x plus 35 equals 11.
Mm-hmm.
And then you can subtract 35 from both sides. So 8x equals negative 24. So that means if you divide them, x equals negative 3.
Great.
Yeah, that was perfect. Great job.
What's y?
And then now y.
So if x is negative 3, then y, so you could substitute this back into the equation, like the first one, maybe. 2x equals y minus 7. So if x equals negative 3, so negative 6x, negative 6 equals y minus 7. So you can solve that and add 7 to both sides. So that means y equals 1.
Great.
That was excellent.
That was a perfect explanation. Good job.
So our answer would be negative 3, negative 3 comma 1. Oh, and by the way, everyone who explains is going to get another 2 points. So you guys are earning lots of points today. All right.
All
do you think
right, so
time
it's time for something that everybody has been waiting for. It's the Kahoot! Yay! Okay, so let's play it. It's pretty short. I think it was like 8 when I made it. I could be wrong.
I've already lost.
You're already lost? It's okay, you are doing well. If you've learned at least something, that's good. And based on this next class, we'll just do a little bit of more practice and maybe some more Kahoots.
Haha, first.
Good thing about Kahoot is that it's multiple choice, so if you don't know, you can just guess for now. I think we have more than 3 people in this class. Hopefully. If we just started right now, then everybody's gonna be a winner since there's only 3 places and there's 3 people. Okay, I'm gonna wait for like at least 2 more people to join. Okay, just one more.
There are 12 participants and only 5 on the thing.
Uh-oh, people better hurry up and join or else we won't be able to finish the Kahoot.
All right. Well, 2 of them are us, me and Kayang. So we're doing all right.
Okay, I'm just gonna wait for one more person. Okay, let's start.
Who's Fadas Fadasa?
Good question.
Should we even? Okay, whatever.
Ooh, this one's like the first one we did on the Desmos. The Kahoot is pretty simple, so make sure to actually be careful and make sure you don't click the wrong one. Five seconds. Yay! Okay, so most of us got this one right. So the solution is where the lines meet, and that's right here. And the point is 3, 1. And there's only one solution. That's the only solution. Linear equation. I wonder who that is.
I wonder. What is the solution to the system of equations graph below? All right, so same thing again.
Could you enlarge the picture?
Does this help at all?
It helps.
Okay. Oh, okay, there you go. Yay! Okay, you guys are right. It's almost the same thing. -2, 1 is our only solution. Ooh, Colin moving up. Similar idea. Make sure you look at like the scale. It's not going up by 1 each time, it's going up by 2.
Honestly, even if you did, well, I mean, like this is like honestly the easiest Kahoot we've done so far.
Yeah, I mean, isn't that a relief? Wasn't
No, I
today's?
think the easiest
Yes,
Kahoot we
yes,
did
it
was the
is.
first class's Kahoot.
Yay,
Kahoot
okay.
shows infinitely many solutions.
Somebody who's trying to be silly.
Is infinitely
Yes.
many solutions more than infinite solutions?
They're the same.
Or is it more than many solutions?
Ooh, look at this one carefully. Hint, these lines are parallel.
Yep. What do we know about parallel lines?
I remember this.
Bruh, the screen always lags for me. Like this one time it lagged like 5 seconds.
Oh,
Yeah, same here.
Everyone.
yay,
does for everyone,
everybody,
so it's still
almost
fair.
everybody got it.
What everybody? There's one person who missed it.
I said almost.
No, I heard everybody.
Almost everybody.
Colin had a before. I don't have to.
Okay, now the lines are right on top of each other. So what does that mean?
Maybe the person who keeps
Guy is finally
choosing
right.
blue will get it.
It means that one guy is finally right.
Yay!
Now some
Everybody got it
interest.
right except one
That
person.
one guy isn't finally right. Okay, now this is very suspicious because the person who's been picking infinitely many solutions right now didn't decide to pick it now.
Exactly, that's what I'm
It's very sus of that the imposter.
Tim, I said that he'll finally get one right.
Lag! It still hasn't loaded.
Same here.
Uh-oh. Is it there now?
It's there now.
Now it is.
Sorry, I think.
Imagine it asking us for the thing and being the answer and it being laggy.
Uh-oh. Okay, let's look at this.
Oh no.
So remember, the equal value method is the one where it's like y equals something and y equals something else. And right now it's like that. So you would use
If y equals something, how can it equal something else?
Because those two things add up to thing 1 and thing 2 add up to be y. Thing 3 and thing 4 add up to be
because
y.
the something and the something else are actually the same thing. Very confusing. Now you have to actually solve this. But
it's lagging, so like.
Does this make any sense?
You can use some logic for this one. You don't even have to do any math.
I hope.
Yeah, okay, so 5 people got it. Good job. Yeah, so how is it?
Imagine the one person who said 0, 0.
Wait, back to the one of the methods. If y equals something and y equals something else, well, I don't know what I'm talking about. I should shut up now.
Go on.
Yes, Colin. Yes, you should.
Go on. So y equals something else. And so you can say that the two something else's, they're also equal to each other.
Anyways, so right now, this doesn't make too much sense, does it? 7x plus a number is y. But 7x plus a different number is the same number? Wait, what did I say? 7x plus 5 over 6 is the same number again? Well, that doesn't make any sense. So there's no solution. Ooh, a different person came up.
Do the math.
Last one, double points. I think this one was extra hard, so somebody just guessed. Alright, this one is kind of really hard, so
What is this?
if you just guess, you have a 1/4 chance of getting this right.
That's not a good. Eliminate 2 answers.
It's not green, guys. It's not green.
So it's not green. That still gives us a 0.3333333. No, not a 0. A 3.3. 3.333333333%. A 0.3 overline 3% chance of getting this right. That's still not good enough.
The answer is not my favorite color if you know what my favorite color is.
How are we know personal information? We're not stalkers.
You're supposed to be friends with me and know it.
Yes, I guessed it right! Yes!
Oh my gosh, 4 people guessed it right. Or maybe
I
somebody
guessed it
actually.
right.
That's very lucky.
Did anybody
Imagine
actually
one
see
person
Did
picked blue
anyone
because blue is
actually
their
solve the
favorite color.
question? Probably the linear equations did. Probably it's like one of the hosts. Like it's either Yolanda or Kayong.
It's Kayang.
Kayang. Okay, sorry.
Yeah.
Kayang, are you secretly Wait, no, it's a Yolanda.
No, interrogate
Yeah.
Kaya. Go back to
Kayan is hosting. Like she's presenting, so it's obviously Yolanda. So Yolanda probably already knew the answer beforehand, so she probably knew it. But like 3 other people guessed it right. So will anyone step up and admit they actually did the thing, or what will they do?
Can anybody step up and admit that they only picked their favorite color? And who actually picked
Red isn't
green
mine.
letters with
color of my
with
Red isn't mine.
nothing
Well,
else?
I actually tried to use educational guesses. Like I knew it wasn't yellow because the first one was a negative fraction thing. The green didn't look pleasing to the eye, so boo green.
I just
And so I just picked
did
red
the- I
because
just
it's my
thought that
sister's favorite color.
850 Yeah. I just thought 850 looked too big.
Well, let's see the leaderboard. Or the podium.
I'm pretty sure the blue and red are the same thing.
Colin, I thought you
Yay.
said you were lost. You got 3rd place.
Exactly. Okay.
Like
Great job.
Sharon
to
stepped up
place.
and won.
Great
Yes,
job to
linear
linear
equation.
equation, whoever that is.
Yolanda.
I wonder.
And then great job to the runners-up as well.
Okay, so we
I'm gonna
have,
stay here until you guys end the meeting because why not?
okay, so there's like 10 minutes left, and let's vote. Should we just end 10 minutes early and just, I don't know, talk about random
Until
stuff?
the other class.
Or should we do another question?
Let's
Let
talk.
us leave.
Let's what?
Let's talk.
Anybody want to do math? And anybody want to do extra math, that is.
Nobody wants to do that math.
Okay,
And
then.
what kind of math? What kind of math do you
other
want to
math,
do?
but not this one.
Let's all do calculus.
Woo!